In this video, we're going to learn how to find the solutions to equations of this form. Y multiplied by a function in terms of x and y, dx, plus x multiplied by a function in terms of x and y, dy, and this equal to 0. So if you were given a question that had an equation of this form, and you are required to find out what is going to be the solutions to it, the first thing you need to do, you need to make a v. That is a new variable which you actually want to introduce into this new equation. And that is going to be equal to y multiplied by x. So everywhere you see an x multiplied with a y, that is going to change to a v. Next up, we're going to make a y to be the subject. So that will be y equal to v divided by x. Now you want to differentiate this, and that is actually going to be done with the quotient rule. So dy here is going to be x dv, and that is actually reasonable. In this case, we're taking this x as the v, and u is taken as v rather, that is taken as a u. We know that if you had y equal to u divided by v, if you wanted to differentiate y, that is going to be dy, and you're going to have v du minus u dv. So that will be u dv divided by v squared. So in this case, we know that the v term or the v function in this case is the x. So that is going to be v du. Now u in this case happens to be a v. So that is why you have an x dv. And this will be minus u dv. In this case, we have u to be v, and v is actually the x, so that is going to be dx. And so this will be divided by v squared. And so that is going to be an x squared. So you're going to have that dy is equal to this form. This would actually be very useful as you try to find the answer to this particular form of an equation. Now let us take a question under this expression. And let's say you were given something like this: y multiplied by xy plus 1 dx. Now you need to notice the difference. Here we actually have a y, and this derivative is in terms of x. And that is basically what we want. We want to have the term or the function which is outside of the other function to be a different variable as compared to the derivative. Now here we're going to have an x, and that is multiplied by 1 plus xy plus x squared y squared. And here, of course, we're going to have a dy. All these is equal to 0. And these also works. We have x and we have a dy. So those are different variables, and they are completely equations of that form, which we represented earlier on. So what is the next thing that we need to do here? What is going to be the next step? Now we know that, of course, v must be equal to xy or yx. These two are actually the same. So that is going to be a v. Next up, we need to make a y the subject. That is going to be v divided by x. And so we're going to have dy to be x dv minus v dx, and this will be divided by x squared. So we're going to take all these and plug them back into the original equation. So let us try to do that. I'm going to clear these out because we need some space. So y, we know that y should be, okay, I'm going to wipe it out and write it over here. So let us say I placed it here. We have a y. That is going to be v divided by x. Now bear in mind that is because v is equal to y multiplied by x. So dy that is going to be x dv minus v dx, and this divided by x squared. Okay, so we need to place all of them in perspective. So v will be equal to yx. Now here we have a y. We know that all y's would actually change to functions in terms of v and x. So y should be v divided by x. So this is going to be v over x. And here we have an xy. Now xy is the same thing as yx. Now we said that every yx should be replaced with a v. So in this case, we're going to have a v there. And on this side, we're going to have a 1. We have a dx. Now here we have an x and we have a 1. And x, y, that is the same thing as a v. And we have x squared, y squared. What do you think that is going to be? Bear in mind, if you have y squared, x squared, that is the same thing as xy all squared. Because we can basically distribute these powers to the two variables or terms which are there. So in this case, we should basically have a v squared. So I'm going to take these out. This is a v squared. And then we need dy. dy in this case is going to be this stuff. So I'm going to place it there. This will be x dv minus v dx. And this is divided by x squared. So this will be equal to a 0. Here now I think I can wipe these out. Now, what is the next thing that we need to do? How are we going to solve this? Now, further on, we need to take everything in terms of v and in terms of x and take it back to look like the linear but not homogeneous equations. We have actually done that in a previous video, and if you have not actually gone through that video, I would actually recommend that you do so. I have actually linked that video to this video in the description section. So feel free to check that out when you got the time. So we actually want to have dv divided by every function in terms of v this way. And that might be a plus or a negative. And you should have a dx divided by dx equal to 0. All these stuff which you have here, we actually want to change it and take it to this form. So that is the next task that we need to fulfill. Now, how can we do that? And the first step, we need to make every variable of x to leave the position where you have v's, and take the v's and bring them together to the position where you have dv's. So the first thing I'm going to do, I know that this is going to cancel some stuff out here. Because this is x multiplied by this stuff, and that is multiplied by this bracket. So x can cancel these out. And so we're going to have a v divided by x. This is a v plus 1. dx plus 1 plus v squared. And here we have x dv divided by v dx divided by x. And this is equal to 0. Now what is going to be the next step? Now, it is actually possible for us to do something else. We can multiply through by an x. If we multiply this stuff by an x, that x is going to cancel this x. And if we multiply this stuff by x, that is going to cancel these out. So we want to do that. So I'm just going to multiply this one by x. I think I'm going to write it in blue. So let us multiply that with an x, and we're going to do that on this side also. So this should be an x. Now this x is going to cancel this, and that will take us to a v multiplied by v plus 1 dx. And on this side we're going to have a 1 plus v squared. And here we have these x canceling these out. So this will leave us with an x dv minus v dx. That is equal to 0. I think I can wipe these out and just leave that one out and clear these. Yeah. Yeah. Now what is the next thing? We have this whole form bearing v's, and that is dx attached to it, which is not completely correct. We're actually going to take them out, but we're not going to do that just yet. We want to make all these dv's together up to one place, or dx's rather. So how can we do that? How can we make that to come? So we're going to have v into v plus 1 dx, and here we're going to have 1 plus v squared, and that will be multiplied by x dv, and we have this stuff going to the other side. Okay, now I think I mustn't do that. I'm just going to change the course of action. Instead of doing that, let us divide through by this stuff. This will give us a better looking stuff. So divide through. That is divide through by 1 plus v plus a v squared. So that will take this to this side, and we're going to have a v multiplied by v plus 1, and that is divided by dx. This will be, well, that is multiplied by dx rather. And here we have divided by 1 plus v plus a v squared. And on this side, we're going to have x dv minus v dx. This is equal to 0. Now, we have all these forms in terms of v. It happens to be that we have a dx here, and that needs to be brought to this other side. So how can we do that? First off, I'm going to take them out. So we should have a v multiplied by v plus 1 dx. This is equal to 1 plus v plus a v squared, and I'm actually going to have a negative v dx. We're going to have an x dv right here. So this is equal to 0. Now, we can factor these ones out. So what will that give? This is going to be a v. So I'm going to draw out a bracket for that. We have a v multiplied by v plus 1, and this is divided by 1 plus v plus a v squared. And this is minus v. And all this is actually multiplied by dx plus x dv. And this is equal to 0. Now, we know that we have a dx here, which is attached to forms in terms of v, and we have a dv attached to a term in front of an x. So we're going to work these out first of all. So how can we do it? I'm actually going to do it in this way. Let this be a 1. And we know that the LCM, the lowest common multiple between this denominator and this, is going to be this form. So that is going to be a 1 plus a v plus a v squared. Now if you took this and divided it into this stuff, you're going to have a 1. So this should be a v multiplied by v plus 1. And here you're going to have a 1 into this stuff, which is basically going to give you the same stuff. And we're going to use that to multiply with the v. So that is going to be a negative v multiplied by 1 plus v plus a v squared. And here you have a dx. So I'm going to write the dx here. And this is x dv. This is equal to 0. Now let us try to work it. We know that if we want to do this stuff, we can actually factor some stuff away from here. Is that possible? So how can we factor some stuff? Now what I actually want to do is I know that we have a v here and we have another v here. So instead of doing this, I'm actually going to factor out the v's. So if we factored it out, we're going to have this stuff. We would have v plus 1, and that will be a minus 1 plus a v plus a v squared. That is what we're going to have on top of that place. And below, this is going to be a plus v, 1 plus v plus v squared. And that is dx plus x dv. And this is equal to 0. Now we know this stuff is going to open up, and we would have a v cancel these v out. And this is going to cancel this out. And that should leave us with this. This is v. And here we're going to have a minus v squared. This is divided by 1 plus v squared dx. This is plus nx dv. This is equal to 0. And we know if these two stuff are multiplied, we should have a negative 3v to the third. So I actually made a mistake here. There should be a 3. So that is, well, what a mistake. This is a minus v to the third. This is divided by 1 plus v squared dx plus x dv. This is equal to 0. So what is going to be the next step? Gradually, we're closing in to exactly what we want to find. Now we need to take this and bring it to this other side. And we also need to take this and bring it to the other side. So how can we do that? First off, I'm going to take the reciprocal of this and multiply it to both sides. So that will look something like this. This is minus v to the third. This is divided by 1 plus v plus a v to the third. Well, that should be v squared rather. And here we have okay, I'm just going to write everything out. So this is a dx. And here we have an x. And this is a dv. And this is equal to 0. And so I am basically multiplying this by this stuff. So this is 1 plus v plus a v squared. And that is divided by negative v cubed. So of course, that is going to help us to cancel these stuff out on this side. But bear in mind, we're not just using this to multiply it with the first term. We need to multiply to each term within this equation. So next up, we need to take this and multiply with this system. So that is going to give us, on this side, we should just have a dx. And this is going to be an x multiplied by this stuff. So this is going to be 1 plus a v to the second, or v squared, minus v to the third. And this is dv. And of course, on this other side, we should, well, have a 0. Now, next up, we need to take the x away from here. How can we do that? We also need to multiply through the whole equation by the reciprocal of the x. So that is going to be 1 divided by x. That is going to take 1 over x to this side. And for this one, that is going to get cancelled. So this will get cancelled. And that should give us a new form of the system. That will be a 1 divided by x. So this should be x. And this is dx. Here now we're going to have a minus. This is 1 plus a v squared divided by v cubed. Notice we had a negative override the plus, and that created a negative there. And so you're going to have a dv here, and this will be a 0. So that is what you have there. And now we could well split this stuff. Of course, from here we can integrate both sides, but I just want to make it more basic, so we should go a little bit further. This is gonna be a minus 1 over v to the third dv, and here we're gonna have this would cancel some stuff here and create a v squared, so that should be 1 divided by v squared dv, and this is going to cancel stuff and leave us with the 1 over v. So this is 1 divided by 1 over v dv, and this is equal to 0. So here now we can integrate both sides. So each term of both sides should be integrated. So this is integral 1 over x dx, and this is minus integral 1 over v to the third. So what I'm going to do, I just want to slow down. Now, should I say slow down? Because what I want to do here, instead of writing it in this form, I will take it and make it to look this way. We know that 1 over v to the third could also be written as v to the negative 3 dv. This is way better. Now this is going to give us v to the negative 2, and that is dv. And here we're just going to have an integral 1 over v. That is pretty obvious. So this should also be an integral. Now the reason why we left this is because if you made v to the negative 1 and integrated this, the answer doesn't actually exist. So instead of doing that, we know that integration is the antiderivative of a function. We know that if we differentiated ln v, that should have given us a 1 over v. Now instead of having the differential for this form, we're going to have the antiderivative of this. Now the antiderivative is going to change this stuff to the original form. That is basically the task or the job of integration. So instead of doing that, we're going to leave this. So we know that 1 over v came from an ln v. Hopefully you understand the point. So I'm taking these out. I'm also going to take these out. Now for this one, we're going to have an ln x. And on this other side, we would have a minus. I need to write this out. This is a v raised to the power negative 3 plus 1. And that will be divided by negative 3 plus 1 from the power rule of integration. Then on this side, we're going to have a v raised to the power of negative 2 plus 1. And that is divided by negative 2 plus 1. That is the third. And the last one, we should have a normal ln v. And on this other side, we should have a constant. So we're just going to have that constant right in there. So this gives us an ln x. And here we're going to have a minus. Should we have a minus? We know that a negative 3 plus 1 is going to give us a negative 2. So if you have a negative 2 multiply with a negative here, that is going to give us a plus. So this is 1 over 2. And here we're going to have v. V will be raised to the power of a negative 2. And here also we're going to have a canceling. So this should be a plus. And this will be a v raised to the power of a negative 1. And this is minus ln v. On this side, we're going to have a simple constant. Like that. Now this stuff can be changed. So this is ln x plus 1 over 2. Now I might not really want to write it that way. We could just write it as a 2v squared. And this is plus 1 over v minus ln v, and this is equal to a constant. Now we already know what a v was. V was given as y multiplied by x. So the last thing I need to do, I just need to replace a v with the yx. And this is going to be squared. And then you're going to have 1 over v. Now we know that a v That is yx. So I'm just going to write that as a yx. And this is minus ln v. That will be equal to a constant. I'm just going to leave that there. Now, if you wanted, you could actually leave it in this form. If you don't want to do it that way, you could take it a bit further, and that will look like this. So this is going to be 1 divided by 2y squared x squared. And here we're going to have a 1 divided by a yx minus ln v. And that is equal to a constant. So this is basically what you want. This is what you're looking for. This will be the solutions. This would actually be the solution to the differential function which was given initially. This one. So now you can see that you know how to solve equations of these forms. So that is basically it for this video. Do have a nice day. Don't forget to subscribe to this channel as well as click the notification button in order to get every upload that will be poured out there every single time.